I have got a very special video to show you today featuring two homemade machines you might not have seen before. We're going to do some testing and also have a close look at the details of both machines. It's a 4-hour drive to the place where I'm meeting two helicopter builders. It's a bit like a fly-in, but we're driving there. Stopping on the way, I can highly recommend Gloucester Services. Pork and honey sausages and chips, absolutely lovely. I would have shown you how good it looked, but I'm afraid I ate it, so you'll just have to use your imagination. The pork sausages were on the right and the chips were on the left, if that helps. Actually, I can draw you a little diagram here and that should clear things up a bit. The first builder some of you will already have heard of, and that is Mr. Ben Cope. I must congratulate Ben on having such a fantastic name. His parents obviously had extremely good taste. Somehow, over the years, Ben has designed and built 5 helicopters, all of which were capable of getting off the ground, and he's nearing completion on his 6th, and we will take a close look at his progress. Some of the previous models are on Ben's YouTube channels, and I will link to those in the description. The second builder is Mr. Julian Mills, a time-served apprentice from British Aerospace. Julian has built an incredible helicopter, and we'll take a good look at that. Julian's a little reluctant to be on camera on this occasion. Maybe at some point in the future we will get him on the channel. I had loads of really helpful comments in the last video about my engine misfire issue, which I believe is now solved. I'll show you what I did to find the issue at the end of the video. On arrival, we discovered that one of my skid legs had broken due to transport. It broke from the bolt hole as a result of bad design. Ben and Julian quickly went into workshop mode, and within an hour it was repaired so I could do some testing. The windsock in the background here gives you an idea of the conditions. Too gusty for any real hovering attempts, but I want to check the engine is fixed and put some time on the new drive shaft. I'm expecting the drive shaft to gradually bind up over time, but we will see. Let's have a listen out for any engine misfires. No misfiring, and I stopped when the engine temperature got to 80 degrees Celsius. The run time was about a minute and the outside air temperature was about 30 degrees Celsius. Very hot and humid, not good conditions for helicopters and particularly mine. However, there was nothing to fix and I can proceed to the next run, which doesn't go as smoothly. You can hear a tinkling sound, which is the drive shaft catching the shroud again. This problem is becoming too frequent, so I'm thinking I might have to increase the diameter of the shroud. Obviously I want the smallest diameter I can get away with, but hitting of course must be avoided. Next we are going to look at Julian's machine. All three helicopters are designed and built from scratch. They are not kits and they are not built from plans. Let's start with the engine on this one, which is a Yamaha RD350LC motorcycle engine. It's a 2-stroke, 2-cylinder, liquid-cooled and produces 50 horsepower. It's being run in second gear and uses the standard motorcycle clutch. Drive from the engine goes to a tractor PTO Sprag and then to a shaft-driven motorcycle right-angle gearbox. The bike the gearbox was used from was a Honda CX500 with a ratio of 3.09 to 1, and that's what's driving the main rotor. The tooth belt is what drives the tail rotor. There is another tooth belt coming off the tail rotor drive shaft that powers a fan. The tail rotor drive shaft runs inside the tail boom to another right-angle gearbox. The tail rotor is a masterpiece of engineering, every part made manually. The rotor has a Delta 3 teeter hinge and is pre-coned. Julian changed the direction of the tail rotor during development for an interesting reason. He realized that making the blades turn upwards towards the main rotor would increase the airflow, utilizing the main rotor downwash. By changing the direction of the tail rotor, he had more tail rotor authority. The main rotor is just as impressive. Again, Delta 3 mixed-fire pitch horns located in a position where rotor flap automatically changes the pitch of the blades. We can observe this pitch change in this clip. The hard part is determining how much pitch to flap coupling there should be, but looking at Robertson rotor heads is a good place to start. The phase lag is also done via this pitch link location, and all the swash plate has to do is point in the direction you wish to travel. The main blades, again built from scratch, have a wooden spar and foam core, and have 6 degrees of twist. Julian said the 6 degrees of twist he later added reduced power consumption by 10% for the same amount of lift. The blades are 8 inches chord, 20-foot diameter and rotate at 450 rpm. That means the tip speed is 471 feet per second. By comparison, I'm running my blades at 580 feet per second, and a Robinson will have a main rotor tip speed of 670 feet per second. However, the high tip speed on a Robinson is to allow a faster aircraft speed, not something that is important on a homemade helicopter. Gauges, we have dual exhaust gas temperature, engine RPM, rotor RPM and cylinder head temperature. Anti-torque pedals are a clever design demonstrated by Julian here. They work a single push-pull cable via a lever. The cyclic and collective mixing is done with this mechanism. Julian built this wonderful machine back in the 90s and it's still fully operational. It weighs 390 pounds, and if you take the 50 horsepower it has and the standard 12 pounds of lift per horsepower, we can calculate it has ample performance. The rotor head has recently been redesigned and Julian is just going to carry out some ground testing here, but hopefully we'll get to see the machine fly in a future video. Julian has dynamically balanced and tracked the rotors.
Yeah, you've gone through the tail vibration.
Yeah. Nice breeze.
Yeah. All off that because there's nothing on the wind side.
Yeah. Now for a close look at Ben's new machine. Ben has used a BMW R1100 RS, which is a 4-stroke air-cooled cylinders but oil-cooled heads. The operating RPM will be around 5,000, and that's a nice low RPM to be running at. The machine weighs 503 pounds with pilot, so he's going to have plenty of performance with that BMW engine. Ben has gone for the same type 90-degree motorcycle gearbox and that will be driven via a chain from the engine crankshaft. The tail rotor is driven using V-belts, and the tail rotor blades are made from pre-preg carbon fibre. This is a similar technique to how Ben constructed the main blades, and Ben now explains how he did it.
The blades are, they're profiled around a dozen formers which my friend Julian had cut for me, and they're all fed onto a 3/4 diameter tube, 25% here, and lined up on using a piece of 4x2 channel. And then I filled in the gaps with foam, then applied 3 layers of carbon fibre and doubled up on the trailing edge so that I could bond those 2 pieces together, and laminated it with polyester resin rather than using a pre-preg, because it was difficult to compress and vacuum form this, so I decided to do a wet layer and then just hand finished it to get a nice smooth finish. Super. The bare blade, minus the weight of the grips and the bearings, is 11 pounds. Total weight, when I added the bearing weight and the extra weight of the extra thickness here, that adds another 6 pounds onto the blade. So I could work the centrifugal force out, knowing the exact weight from where it's taken the pull.
Oh yes, yeah.
Here is something very interesting. JLCMC sell a ball spline. This is a spline shaft but runs on recirculating ball bearings. I knew ball splines existed, but they are normally very expensive. What JLCMC sell is much more affordable. If my drive shaft binds up and I can't solve the issue, what about this ball spline as an alternative? I need to check the specifications, maximum torque, maximum RPM and weight for example, but I think it looks promising. What I do need from JLCMC on this occasion is some grease nipples. During testing one day, one of my nipples fell off. Must have been the vibration, and so I need a replacement. However, my previous nipples were bent at an angle that prevented adequate access with my grease gun. The new nipples with improved angle are just a job. Thanks very much to JLCMC for the grease nipples and sponsoring this video.
A simple process: you just cut a strip of pre-preg carbon, pull it tightly around the tube, and I have some stuff called shrink tape which we again bind it, and then apply 100 degrees for 1 hour, and it's cured.
Right.
And it's impossible unless you grind it off. It grips the tube so tightly, it's there for life really.
Wonderful.
And it obviously stiffens the tube, which is why it's there, just to stiffen these tubes where they were tending to flex.
Yeah.
This is interesting. These aluminium tubes are wrapped in carbon fibre. This stiffens the tube and helps reduce vibration, but you are still using a tube that will bend if overloaded, rather than just suddenly break if only using carbon. This is something that could help me. I have a vibration issue with my control rods, and wrapping in carbon could solve my issue without adding very much weight. Ben very generously gave me some carbon fibre to take home and try. It needs to be kept in a freezer, and I was also given that by a family friend when I got home. Thank you to Ben Cope and also to the Colliers. The cyclic and collective mechanism is demonstrated here, and it's beautifully made.
The rest is glass fibre. It's just the binnacle that's carbon.
Mm-hmm. And the moulding process was?
I made a plywood, bent a sheet of plywood to a shape, curvature that suited me.
Yeah.
Painted it, gel coated it, laid up this inside this mould, and it was a split mould, so I took the 2 halves together and this dropped out.
Yeah.
It's relatively light. I think it weighs about 12 pounds.
Left to do on this helicopter is the main and tail rotor heads. Not a huge amount, and knowing how quickly Ben works, I doubt it will take him very long. What I find quite amazing about Ben is his drive and ingenuity. Knowing what it takes to build one helicopter, I really don't know how on earth he's made nearly 6 of them. I find that quite astonishing. I found it very inspiring to meet Julian and Ben. The knowledge and enthusiasm they demonstrate is something that can only be admired. Ben and his family very kindly invited me to stay at their home for the weekend, having never met me in person. This shows what lovely people they are. And now to reveal what a lot of people have been wondering. What was the cause of the engine misfire? A few comments saying the crankshaft seal I installed is now backwards because the crankcase is operating in a vacuum. Good point. I think I should turn that back around. I noticed near the seal was some oil on a bolt head. I traced that back to a loose bolt on the reed valve cover. All the other bolts were tight, just that one loose for some reason. I started the engine in the hope that that was the issue, but it wasn't. I then removed the spark plugs to see if there was any information to be gained. Nothing was obvious to me. After the engine run, I removed the carburetor drain plugs to see how much fuel was in each float bowl. They seemed about the same. Manually pumping the fuel bowl makes no difference to how the engine runs, so I think that rules out a fuel pump problem. It was suggested in the comments to swap the carbs and see if the problem transfers to the other cylinder. Excellent idea, and it's easier than I thought. While the carbs were off, I checked the condition of the reed valves. Nothing obviously wrong I could see. With the carbs swapped over, the problem cylinder is now firing. When I open the throttle on each carb, it's very evident the top carburetor has a problem. This is the third time the problem carburetor has been apart, and again all jets are clear. The only difference this time is I poked some lock wire through every hole I could find. I didn't notice any blockage, but hopefully something has been cleared. And yes, it's now running on both cylinders again, but it sounds a little different this time. As we know, it's been running fine since. What's confusing is why in the past attempted carb cleaning resulted in running fine for a little while and then the misfire. Of course, I also had a cylinder head leak and weak stroke intermittent spark on the same cylinder at the same time as the intermittent carb blockage. Then I also had a dodgy connector on the new CDI unit I bought, which just added to the fun. I really like it when the electric wire helicopter people come to check the lines. They always give me a wave. I'll sort the small issues on my machine and wait for a calm day for the next video. I need to have a think about what I'm going to do about this broken leg. Now this is actually quite interesting because you can see it's split from the bolt, and that's no coincidence. What I did not realize until this weekend was that if you put a bolt through this direction and you try to bend it up or down, the point at the most stress is where the bolt is. So if we look at this bent bit of tube here, we can see that the top is stretched and the bottom is under compression. The bit in the middle really isn't doing a lot. So if I put a bolt right through, I'm putting a bolt right through that highest point of stress. And it's the same here. You try and bend a straight bit of tube, the highest point of stress is where you put the bolt if you're bending it up or down in this kind of plane. Therefore, I need to think about perhaps putting a bolt through that way, because that's the point at which there's no stress, is through that direction. That's one option. The other option is to insert a bit of tube inside here. I've had a bit of tube going from there probably all the way to there because I want to include this bend. This tube is 1.6mm wool, but if I put another bit of 1.6mm wool inside that, that will give me 3.2 where I need it to be extra strong. The other thing I can do is do what this strap is doing and put a bit of cable between the two legs in order to stop them spreading apart. What I don't want is any kind of cable snagging on anything on the ground. I think if I moved it up a bit, up to about there, put a drilled hole through this direction in the leg, we know that is strong, and put a cable between those two bits a bit higher up. The other option, of course, is to keep this 1.6mm wool but put the bolt through that direction and have the cable as well. In order to get the bolt through in that direction,
I'd have to redesign the bracket. Maybe some loops that go up around. I don't know. I'll have to think about how that can work. A passing thought. I don't know what's made me think of this, but something did, obviously. You know those people that when they want to change the page of a book or a magazine like this, they lick their finger like that so it sticks. Now, I've never been keen on that. I always remember my granddad sitting at the kitchen table reading a newspaper, and every page was lick the finger, stick it on, and of course you can open your page. And then in those days the newspaper used to get sent off to the chip shop and they used to wrap people's chips in it. I've never been a fan of that, personally. Same with envelopes. You know, you lick the envelope, don't you? Don't like it. For those people that do that, do you do that with toilet paper? Think about it.